Hello everybody, welcome from HVACR Design Engineering. I am Tuyao. Now I want to talk about Evaporator process on pressure enthalpy diagram. The refrigerant entering the evaporator is a cool partial liquid vapor mixture. The operating pressure and temperature of the evaporator is called the suction pressure and suction temperature. This suction line is the piping that route refrigerant gas from the evaporator to the compressor. It is important to note that in the mist region, the pressure and temperature are dependent variable. For example, if a compressor operates at a suction pressure of 36.8 psi, and then the corresponding evaporator pressure is 36.8 psi and the corresponding evaporator temperature is 25 degrees Fahrenheit. Figure for point A and B. Value are for refrigerant R134A. If the compressor operates at suction pressure of 49.7 psi, then the corresponding evaporator pressure is also 49.7 psi and evaporator temperature is 40 degrees Fahrenheit. The evaporator moves the refrigerant from point A, partial liquid vapor mixture, to point B, a fully saturated vapor refrigerant. As the evaporator transfers heat to the refrigerant, there is no gain in temperature. All the heat is used to convert the remaining liquid to a gas. In an ideal evaporator, there is just enough heat transfer to convert all the liquid to gas and nothing more. Thus, the output of an ideal evaporator is 100% vapor at the same entering temperature referred to figure. In this figure, we see that as the refrigerant moves through the evaporator, the temperature remains the same, and the percent of vapor increases and it reaches saturation. Also introduced in the figure above is the term superheat. If additional heat were added to the 100% vapor refrigerant, then the heat will be used to increase the temperature, and it is increase in temperature that is called superheat. In the figure, an evaporator with 15 degrees Fahrenheit superheat is shown. The refrigerant reached 100% vapor prior to leaving the evaporator. All the additional heat from this point is used to increase the temperature of the refrigerant, and it reached a temperature of 40 degrees Fahrenheit. The refrigeration has a superheat of 15 degrees Fahrenheit because the final temperature is 15 degrees past the saturation temperature of 25 degrees Fahrenheit. It is important to note that the pressure remains constant throughout the evaporator. On the pressure enthalpy diagram, superheat is shown as horizontal movement along the suction pressure line past the 100% vapor gap. The figure shows the difference between 0 degree Fahrenheit and 15 degree Fahrenheit superheat. Point B is the 100% vapor point at a constant evaporator or suction pressure of 36.8 psi and a temperature of 25 degree Fahrenheit. Point B1 results from additional heat or enthalpy added to the refrigerant. The refrigerant moves from point B to point B1 where the resulting temperature is 40 degree Fahrenheit. Thank you very much for watching my video.